Hello everyone, we are House Dealer. Today we are going to talk about the project. I focus on the feature engineering. There are mainly the following four parts: imputing missing values, feature crossing, highly skilled variables correction, encoding and scaling. First, imputing missing values. We can say some features have a lot of missing value by the cloud. According to the features, we use four methods to impute the missing value. Using missing to impute categorical data with which NA means something, using mode to impute other categorical data, using zero to impute some data, using iterative imputer to impute the remaining data. Feature crossing. This part can significantly reduce RMSE. Before feature crossing, we establish ranking among categories within a field of features. Ranking is based on the median sale price they show for each category. We mainly use for arithmetic operations to establish new features. Multiplication, subtraction, house age, like age year build is year sold minus year build. Division, average value, like this one. Addition. Finally, we establish 17 synthetic features. Highly skilled variables correction. We identify any variable with skewness greater than 5, then apply Yale-Johnson transformation on them. When we apply the transformation based on the +1 or -1 threshold, RMC significantly increases. With trial and error, we settle on the threshold of 5. Encoding and scaling. We apply one-hot encoding on category codes and scaling on numericals. Then we will make the transformed variables go through various threshold.
Hi everyone, I'm focusing on model and cross-validation. For the model part, we first try some linear regression models, and we use ridge regression, lasso, and elastic net model. Ridge regression and lasso are similar. The difference is ridge regression uses L2 norm of weight for the loss function, and lasso uses L1 norm. And elastic net use both L1 norm and L2 norm. We use this model mainly to solve the overfitting problem. And we also use SVR model. It is similar with SVM model. And the main idea of SVR is to make the distance of the farthest point to the hyperplane the smallest. Then we use GBDT model, XGBoost model, and LightGBM model. They are based on tree model. The main idea of GBDT model is to build a tree model and then use another tree model to feed the residual error and keep doing it. The GBDT model uses first-order Taylor expansion. And we also use LightGBM model. It is based on histogram decision tree model, and it has a better precision and run more effectively. We also did ensemble learning like stacking and blending. And the structure of our model is like the picture. And finally, we did k-fold cross-validation. It is also used to solve overfitting problem, and it helps a lot to do with the parameter training.
In this part, I will briefly introduce two methods we use to calculate the feature importance. First one is feature gain. This is a common method mainly used for tree-based models to search for the best segmentation. Here, we use built-in method to get the importance score and plot the feature importance for each feature. Then, to dive deeper into most important features, we use Bruta with SHAP algorithm. It is a newly proposed algorithm which has proven to outperform the original permutation importance method. In the last part, I will discuss our three main findings: feature crossing, model iteration, and overfitting and underfitting. This is a comparison between before and after adding crossing features. The RMSE score is decreased by 5.1%. This tells us data and features determine the upper limit of machine learning, and models only approach that upper limit. We also implement various models, including linear regression-based, SVM-based, tree-based, and ensemble learning-based models. Almost every iteration results in an improvement. We find that high nonlinearity and ensemble learning makes the prediction perfect. To avoid underfitting, we do feature engineering to make data express the problem in detail. We also increase model complexity by using thousands of estimators and boosting to decrease bias. To avoid overfitting, we do data cleaning, add regularization term, perturb training set, use cross-validation, and blend models to decrease variance. That's all. Thank you.